Hi everyone! In this video we will subtract rational expressions with different denominators. Subtract r divided by r minus 7 minus r minus 4 divided by r plus 7. We need to find the lowest common denominator. The first denominator has a binomial of r minus 7. The second denominator has a binomial of r plus 7. In finding all of the common factors, we will need to include both of these. So we have r minus 7 and r plus 7 as our lowest common denominator. So our first denominator needs to be multiplied by the r plus 7 binomial. And whatever I do to the denominator, I need to do to the numerator. So we have r plus 7. And for the denominator of the second one, we need to multiply by r minus 7. Which means we also must multiply the numerator by r plus 7, or minus 7. In the first one, we'll go ahead and do the distributive property. So we end up with r squared plus 7r over the lowest common denominator, which we found is r plus 7, r minus 7. And we will subtract on our right side. We're going to need to FOIL to find the product of r minus 4, r minus 7. So we get r squared. And then the outside we get minus 7r. The inside is minus 4r. And the last negative 4 times negative 7 is positive 28. We can combine these two together. Minus 4 minus 7 is a negative 11. So we have r squared minus 11r plus 28 over the denominator, the lowest common denominator of r plus 7, r minus 7. Now we need to subtract, and we are going to be subtracting every single term over here. So let's go ahead and distribute this negative into every single term, giving us subtract r squared plus 11r minus 28. And so we have r squared plus 7r minus r squared plus 11r minus 28 over the common denominator of r plus 7, r minus 7. Now we can combine all like terms. R squared minus r squared is gone. Positive 7r plus 11r gives us 18r. Minus 28, they didn't have anything to combine with. And then our common denominator was r plus 7, r minus 7. And now we have subtracted these rational expressions and simplified it to our 18r minus 28 over r plus 7, r minus 7. And we're all done.